Oh, were you nervous with that pause? And start right away. Changing it up. Welcome to the introduction to trigonometry. Let that ease over yours for a little bit. And I know the first question you have is, what is trigonometry? What is it? Well, that's what trigonometry is. The measurement of triangles. So, trig ratios are our focus. Trig ratios is a ratio of the length of two sides of a right triangle. We're going to use two sides to solve for different things. We can use two sides to solve for the third side. We can also use two sides to solve for a specific angle measurement. That's where we're starting to go today. Or we can use an angle and a side to solve for another side. I'm going to keep smashing to emphasize my point. Today we're going to look at three important ratios. Those are going to be ratio 1, ratio 2, and ratio 3. No, they're not. They are the sine, the cosine, and the tangent. So these right here, those guys, those are talking about side lengths or sides related to the angle you're providing. And you're going to see a diagram with what I mean about that. So the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So we have there's a saying in math, and it is called, ready for this? Work. So stands for sine, opposite, hypotenuse. Just remember what you're working with. Ka stands for cosine, adjacent, hypotenuse. And lastly, here comes, get excited. It's supposed to be more dramatic than that. Fade away. Whoa! TOA stands for TOA, tangent, opposite, adjacent. And again, that's just referring to the side lengths about the angle. So that means, coming at you, close. So if you are asked to solve for angle C, solve for angle C. So this is angle C. So opposite is, again, it's the side the farthest away. Or we refer to it as the side not attached to the angle. Again, or the side that does not create the angle. So opposite, farthest away. Adjacent is our side length that is not the hypotenuse that creates the angle. Because here's our right angle, got lost somewhere. There's our right angle. So we know the hypotenuse. We know that's opposite the right angle. And our adjacent side is just kind of that third side, or the one connected. So just to start, we're going to look at one example of how we use this. So, boom, X, Y, Z. So if I want to find trig ratios for angle Y or Y. So if I want to do that, that means I'm going to look for the sine, the cosine, and the tangent of angle Y. So this is saying sine of angle Y, cosine of angle Y, tangent of angle Y. So again, it's a ratio. So if we're talking about angle Y, here's angle Y. The sine, what is sine? Well, remember, we had this saying. What's our big saying? It's SOHCAHTOA. SOHCAHTOA. So sine is our SO portion. So the sine is our opposite over hypotenuse. We know our hypotenuse is that. So the sine is going to be 24 over 30. So the cosine now, cosine is ka. cosine is adjacent. So since this is opposite, this is hypotenuse, this leaves this to be our adjacent side. So the cosine of y is our adjacent side, 18, over our hypotenuse, which is 30. And then lastly, our tangent of y, tangent, TOA, is opposite over adjacent. That's pretty good. So that's the very, very basics. We're going to get more into this tomorrow with solving. But for right now, these are what we're going to practice tomorrow, is writing just our basic trig ratios. Eventually, we're going to start using angle measurements as well to solve for missing side lengths, missing angles, blah, 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 blah. Good luck, have fun. Take the online quiz. It's one question. It's pretty easy. Stop.